In this video, I'm going to tell you about how to delete the node from the front of a circular linked list. Okay, so here also we are going to have three scenarios. The first scenario is that there are no nodes in the linked list. Okay, the second scenario is that there is only one node in the linked list, and the third scenario is that there are a couple of nodes in the linked list. So what happens if you have got only no nodes in the linked list? In that case, to check if there is no node in the linked list, we will see if head equals null. Okay, that indicates that there is no node in the linked list, and then we can print if the list is empty. Okay, so if there are no nodes in the linked list, okay, we are going to print the list is empty. Now that is the first case. Now we'll come to the second case. Now the first thing is that how would you understand that there is only one node? The condition is that if head's link is equal to head, that means that your linked list is going to have only one node. So we are going to write the condition if head's link equals head. Okay, that means there is only one node. In that case, and always remember one thing, whenever you are deleting a node, you should always print the data part of that node. Okay, so you can as a programmer you can understand which node is deleted. Okay, so if this is the condition, then what we are going to do, we will print this data, that is printf %d, and it is pointed by head, so head's data. Okay, so once it is done, now we can free this space. Okay, so we write free head, so this node will be removed, and then we are going to place the value of head as null, so head will be updated as null. Okay, so these are the things we can do when there is only one node. Now we'll see the third case where there are a couple of nodes in the CSLL, and we want to remove the first node because we want to delete from the front of the list. That means this node with a value of 100 should be deleted. So in that case, what we have to do, so the logic is given here in this diagram. We have to first point a pointer to the first node. So we have to declare a pointer and then it should point to the first node, and then we are going to move this pointer temp1 to the last node. Okay, once we move it to the last node, then the second step is that the head is pointing to the first node, the head will point to the second node. Okay, so you can make it head equal to head's link, so head will point to the second node, and next you can free this space because the temp1 is pointing here and this link is having the address of the first node. So using the temp1 you can easily free this node. After you free this link should have the address of head because head is going to point here. Okay, already we have in the second step we have moved the head from the first node to the current first node. Okay, so this is what we need to do in order to remove the front of the first node from the linked list. Okay, so let us write the code. So we assume that it's already temp1 pointer is being declared and we are putting temp1 equal to head. After that we want to make the temp1 to point to the last node. So how you can move it? So you can write temp1's link, okay, not equal to head. Okay, so you have to move your temp1 is equal to temp1's link. So your temp1 is going to move. Okay, so temp1's link not equal to head, so this is not equal to head, not equal to head, and when it comes it is equal to head, so it is not going to, it is going to come here and it will stop. Okay, And after that, once it is done, we are going to move our head from the first node to the second node, because your second node is going to become the present first node. So we have to write just a small code. Head is equal to heads link. Why? Because head links is having the address of this node. So when you are putting head is equal to heads link, so head is going to be updated with the address of this. That means head will be pointing here, right? And once that is done, we are going to display the data using this temp1. That is one way. We can write here printf %d, because we want to delete that. So before deletion, you have to display the data. So you can write temp1's links data. So here what is happening? Temp1's link is what? This value. It is pointing to here, and its data, which is 100. So that will be displayed. After that, using the temp1, we want to free this. So we will write free temp1's link. So temp1's link is this red line which is pointing to here. So this node will be freed. After that, temp1's link, we want to point it to the second node, because head is already now pointing here. So we have to write here. So we're going to write here temp1's link equals head. So that's all. When we write this, okay, your node at the beginning of the CSLL is deleted. So here we are going to write a function for all these three cases, three scenarios. Okay, so we are going to write, and what are the pointers required? We have a pointer called temp1. Okay, so we are going to write void delete at front. So this is the name of the function we are giving, and then we will take the first scenario. But before that, let us declare the temp1. So struct node star temp1, because temp1 is a pointer, and then we will take the first scenario. The first scenario is that if head is equal to null. So we are writing if head is equal to null, then we have to do what? We will print here list is empty. Okay, else we'll go for the second scenario if there is only one node. So we'll say heads link equals head. So in this scenario, which is our second scenario, what will happen? If heads link is equal to head, we are going to print this. Okay, I'll copy paste here, and the next thing is that you have to free the head. Okay, and one more thing is that you can keep the head equals null. Okay, and then you can give your semicolon. So we have to free head, and then make the head equal to null, because once the node is free, the head is not pointing to anyone, and that's all. Else we come to the third scenario. Third scenario is this entire one, where temp1 we are pointing to the first node, that is which is pointed by head, and then we are going to move the temp1 to the last part, to the last node, right? So how will you understand when it is not equal to head? Okay, and then we keep on upgrading the temp1 to the temp1's link. So that's done. Next is that we can move the head to the So I'll just try to copy this, some of the codes here already written, and this is one beauty of this link, is that you are going to free the node using a pointer which is pointed to the last, and using temp1's link. Okay, you are going to free it, and last you have to do what? Temp1's link is equal to head, because your present head is the first node. Then we are closing this else part, and then we will close this function. Okay, so that is how we can delete the node from the front of the linked list. I hope you have liked this video, and one thing is very important. This entire linked list concept in data structure is very easy than any of the programs in data structure, because the only thing is that you have to draw it and try to make a link. Okay, and once you know this, these things require some sort of practice. If you do the practice, it's very easy for us to write the code. That's all guys. Please like, subscribe and share my videos, and please provide your comments as well. Bye bye.